Okay, so I'm going to talk a little bit about the liver and just some basic functions of what the main purpose of the liver is and what it does. So for our purposes, I just have a very rough schematogram right here with some things outlined that I want to discuss. So first off, we can talk about the hepatic artery, which comes from the heart. Basically, it carries oxygen-rich blood from the heart into the liver. And then we have the hepatic portal vein. This is something that's important when it comes to drug and supplement metabolism and also metabolizing your foods. This comes from the intestines, and what this portal vein does is that it brings nutrient-rich blood into the liver for the liver to then metabolize those nutrients, those drugs or different supplements that we've taken. They get metabolized by cytochrome P450 enzymes. Now I've talked about these enzymes many times in several of my videos. These are the enzymes that are responsible for phase 1 metabolism of drugs. These include enzymes that things like piperine are meant to inhibit, such as CYP3A4. I've done videos on this extensively, so if you want to go check those out, you can check out the video I have on YouTube called Supplement Metabolism Explained. It's all there. I also have an article written on this in the Leviathan Nutrition blog post. You can go check it out there also. So I have plenty of information describing exactly what these P450 enzymes are. So we're not going to get into that here. But basically, this is where most of the metabolism takes place in the liver. And then once this nutrient-rich blood goes through the liver, and this oxygen-rich blood circulates through the liver, we have oxygen deficient blood, which comes out of the liver from the hepatic vein and then goes back into the heart, and then just restarts that cycle, which will then bring oxygen rich blood back to the liver. So here we have the gallbladder. This stores the bile, and then the liver is what creates bile, which will start by synthesizing bile acids. So bile acids are in the liver from cholesterol, and then bile is made and stored in the gallbladder. So bile is essentially made up of mostly water. It's about 95% water, and about 5% of that are these bile salts and some other fat-soluble compounds. So once bile is made from the liver, bile is then stored in the gallbladder, and then the gallbladder is sent a signal to excrete that bile to aid in digestion and things like that. So the bile then gets released from the gallbladder, flows through the common bile duct into what is known as the duodenum. This is the beginning part of the small intestine, basically. Okay, so this bile then enters the duodenum. So whenever it enters the duodenum, we find a physiological change in pH. The pH in the duodenum is around 6. This makes it more acidic. So this is where the point is made that bile salts are going to be more effective than bile acids at fat digestion and things like that, which is why it's important that we have these conjugated bile acids that have been conjugated with either taurine or with glycine. TUDCA is an example of a bile acid that has been conjugated with taurine. You have the original bile acid UDCA, which I'm sure many of you have heard of. It gets conjugated with this taurine, so the taurine molecule attaches to this UDCA, and now it is known as TUDCA. What this does, whenever this taurine molecule attaches, is it lowers the pKa of the molecule, what this means is that whenever this bile salt comes into the small intestine, it's going to have a negative charge on it, which the UDCA or the bile acid would not be negatively charged. So at this point, when bile salts enter the small intestine, they are ions, which means they have a negative charge because of this specific pH and the properties of these molecules. So in essence, this negative charge is going to overall make these bile salts more effective at what is known as emulsifying fats, which is basically mixing these fats combining them with the bile salts and the water to all be able to go through the intestines as a well put together mixture, rather than being completely separated like you would normally see if you were to drop some olive oil in water. You can see that the droplets of olive oil do not mix well with the water. So with these ionized bile salts, you are able to mix this oil that would otherwise not be able to mix in water more effectively, and because of this, they're able to go through and become absorbed through the small intestine and then broken down and digested much better than if you did not have bile salts at all. So the bile salts then mix or emulsify with the fats and digest them through the small intestine. So once the work of these bile salts are done and that fat has been absorbed in our bodies and thoroughly digested, these bile salts then return to the liver to continue doing this job all over again.